In this clip I'll be showing you how to find the equation of a tangent to a curve. Now in this example I've drawn the curve y equals x squared plus 2x plus 1, a parabola of course, and you can see that I've drawn a tangent in at the point 1, 4, and my job is really to find the equation of that tangent. So whenever we're finding an equation of a tangent, we know we're up for differentiation. Okay, we're going to have to find the derivative of y equals x squared plus 2x plus 1. Okay, so the derivative of that is quite simply, so y dash equals 2x plus 2, isn't it? Okay, that's the derivative of y. Now what that enables me to do is find the gradient at any point on the curve, the gradient of a tangent. Okay, so my point of interest is at 1, 4. So to find the gradient of the tangent at that point, I simply substitute the 1 into my gradient equation. Okay, so I discover that y dash 1 is equal to 2 lots of 1 plus 2, and that equals 4. Okay, now if I'm after an equation of a tangent, it's going to be of this form: y equals mx plus c. I've already found m, it is equal to 4. Okay, so far I can say that the equation of my tangent is y equals 4x plus c. My only job now is to find the value of c. Now to find the value of c, all I need to know is one point on the tangent. Well, I've got that point, it's up here, 1, 4. It's on the parabola, but it's also on the tangent, isn't it? So what this is saying is when x is 1, y is 4. And I can substitute that into my equation right here. So when x is 1, y is 4. So really, I can say, therefore, 4 is equal to 4 lots of x is 1 plus c. And we can see from that, 0, because I'm taking 4 from both sides, is equal to c. That means the equation of my tangent is y equals 4x plus 0. Well, I don't need the 0, it's just y equals 4x. So that's our first example. Okay, to our second example now. I'm interested in finding the equation of the tangent to the curve y equals 4x minus 1 on x, where x is equal to 1 on that curve. Now we don't really need to know what it looks like, this curve, but it is in fact a hyperbola, 2 branches there, and at x equals 1 on the curve, you can see we've got the tangent going, and my job is to find the equation of that tangent. Okay, so, well, we know we're up for differentiation, don't we? So y dash in this case, well, before we find out what y dash is, let's put this in what I call calculus friendly form. I don't like having this 1 over x there, it makes it hard to perform the differentiation. So we're going to make use of our index laws and say that y is equal to 4x, not touching that, minus x to the power of negative 1. I hope you recall all that about our index laws. If not, see the clip about it that I've produced. Now we're ready to find the derivative of that, so dy dx, or just y dash if you prefer, is equal to 4 now. Minus, what have we got here? We bring the negative 1 out front, so negative 1 times negative 1 really is plus 1, isn't it? And then we reduce the index by 1. Okay, so that's the derivative. That's also equal to, of course, 4 plus 1 on x squared. Okay, now what that's going to enable us to do is find the gradient of the tangent to any point on that curve. So now we're interested in where x is equal to 1, aren't we? So what I'm going to do is substitute x equals 1 at x equals 1, dy dx is equal to 4 plus 1 over 1 squared, which is just 1. Okay, and that's going to equal 5. Alright, so that's telling me the gradient of our tangent to the curve is 5. Okay, so now don't forget what we're after here is a is an equation of this form: y equals mx plus c. And we already know what m is. It is equal to 5, isn't it? So therefore y equals 5x plus c. Now what I need to do is find a value for c. Okay, so what do? Well, I know that going back to my original equation, I know that x is equal to 1, but I don't have a y value, do I? So I'd need to find that. So I've got to go back to my original equation. Now, when x is 1, y is equal to 4 lots of 1 minus 1 on 1, and that's equal to 4 minus 1, which equals 3. So that tangent is that I'm talking about is going to touch the curve when x is 1 and y is 3. Okay, so now I can substitute 1, 3 into this equation right here. And so what I get is this, that 3 equals 5 lots of 1 plus c. Remember, that's what I'm trying to do here, find a value for c. So therefore 3 equals 5 plus c. Therefore c is equal to -2. Therefore the equation of my tangent to the curve when x is equal to 1 is y equals 5x minus 2. And that is how we find the equation of a tangent to a curve.